having more of them. So you're going to have a lot of steps on these equations today. We've done 2-step linear equations. We've done 3-step linear equations. Some of the ones today have 4 or even 5 steps. So you might look at these and go, whoa, which steps do you do first? And I'm going to tell you, the step that you're going to want to do first is the step that most of you are not doing first. So let's say I have 2 times x plus 3 minus 3x equals 4x minus 5 plus 2x. Wow! There's so much to that. Can we do this?
Yeah.
We can do this. Okay, so you might, what are we going to do first? What does order of operations tell us to do first, Tayson? Parentheses. Can I add x plus 3? Please do not add x plus 3. Some of you are still trying to add things that are not like terms. They don't add. But I can multiply this 2 through. And the 2 goes through everything. So what's 2 times x? 2x. What's 2 times 3? 6. Minus 3x equals 4x minus 5 plus 2x. Okay, now this step is the one that, for whatever reason, you guys don't like to do. You like to skip this step, and it's the step that will actually make your life the easiest. Do you guys know what step that is? What do I want to do next? What do I want to do next, Coulter? I want to combine like terms. Your gut is going to be, oh, there's a 2x there, and there's a 3x, so I'm going to minus 2x and minus 2x. Ah! Yeah, but this is what I'm saying. This is great, except for yizaba. I'm going to totally say that. Next time somebody does that on an assignment, which one of you will, I'm going to go yizaba. Because, number one, they're on the same side of the equals. I could subtract 2x over here and subtract 2x over there. That would actually be beneficial. But I'm not going to. I'm going to combine like terms. I'm going to say, how many x terms do I have? 2x terms over here. So I'm going to do 2x minus 3x. What is 2x minus 3x? Negative 1x. Okay? Negative. I'm just going to write the x. Do I need to write the 1?
No.
If you write the 1, is it wrong?
No.
No. Negative x plus 6 equals, okay, now I'm going to combine x's over here. What's 4x plus 2x? 6x. Make sure you're watching the signs. A lot of you are still struggling on your signs. Are we adding? Are we subtracting? Look at the thing in front to double check. And then a minus 5. Well, good golly, is this something I can do?
Yeah.
This is something I can do. Oh, I am so sorry, people. The answer on this one will be ugly, but that's what happens when I just come up with numbers. Okay, do I want to get x terms over here, or do I want to get x terms over here? Why do I want to go right? Or, yeah, right.
So that we don't have to go negative.
We're going to go right so we don't go negative. If you go left, is it wrong?
No.
Just have a negative you need to keep track of. And some of you are, negatives are still vanishing. We're still killing motorcyclists. But they're going to happen. So we have 6 equals, what's 6x plus x? 7x minus 5. Now at this point, this is 2 steps till we're done. Everybody in this room is really pretty solid on doing this stuff. So we're good. So what do I do with this 5? Do not subtract the 6 to get it over with the 5. We want to add the 5 to get it over with the 6. So 6 plus 5 is 11 equals 7x. We're going to divide both sides by 7. And like I said, it's something horrible and ugly. 1.57?
Yeah, 1.57.
Yeah. It's not, I mean, it's 1 4/7. I don't like sevenths. Although I divide a lot of things up into 7 because there's 7 people in my family. So I am good at dividing things into 7, but that doesn't mean I like it. Do you guys see the process that we did though? First, I distributed. Then I gathered all my like terms. Then I got my x's to one side, and I got my numbers to the other. Does it matter which side? Really doesn't matter. You just pick the one that goes for you. And that's it on all of these. I do want to do one with a fraction though. What if I have, I'm going to do one that's similar to one on the assignment. I'm confident we have a fraction on the assignment. Which problem number?
Number 5.
Number 5. I am not going to do number 5. What I will do is super similar to number 5. So whatever you do not think I am doing number 5 and write this down for the answer to number 5.
Could I close the door?
You can close the door. So let's have 3/4 x plus, give me a number.
3.
6. What do you minus 6? Minus 6, what's a lot like? Give me a large number.
157.
157. I want it big. Equals x. Okay, this is great. This is very, very similar to number 5, but it is not number 5. All right, I have a fraction there that's going to cause me some problems if I am not good at manipulating fractions. And quite honestly, I don't want it in my life. So how do I get rid of that fraction? How do I get rid of it, Monica? Times it by 4. Now, here's the deal though. Because this is an equation, if I times one term by 4, I have to times actually, absolutely everything by 4. Can I do that? I can do that. So what is 4 times 3/4 x? 3x. Let's see how he did that. 4 times 3/4 x. And the 4 is canceled, and we're just left with 3x. If it was 4 times just x over 4, the 4's would cancel, and I'd be left with just regular x. But this one has a 3 in it, so it's a 3. 3x. But I'm not done with this 4. This 4 needs to go to this 6. So what kind of 6 is it? Is it a positive 6 or a negative 6? So what's 4 times negative 6? What's 4 times regular 6?
Or 24.
24. And then what's a positive times a negative? So it's negative 24. And then this is going to be fun. What's 4 times 157?
628.
That's 628. And it's positive because we have a positive times a positive. So plus 628. Oh, the math isn't going to be super horrible on that. And then what's 4 times x? 4x. So you guys see how I had to multiply the 4 times everything. And it was a lot of multiplying by 4. So I kind of have to make a choice. Do I want to deal with this fraction for the entire problem? Or do I want to multiply everything by 4? And I chose to multiply everything by 4. Now one thing I could have done at the beginning, I could have combined the 6 and the 157 before I went around multiplying. Because they're the same term, like the same kind. But I didn't, and that's okay. Now I can combine like terms. This is an x term. Does it have any x term buddies on this side of the equation? So I'm just going to bring it down. It's just going to watch what's happening. I have negative 24 plus 628. Can I deal with that? Coulter, how do I deal with that?
You subtract the 24 from the 628 and it becomes 600.
So this is just 604. Oh, this is going to work out pretty, guys. Equals 4x. Is this something I can solve? The numbers are large. Can I still solve it? Yeah, so I have this 3x over here and this 4x over here. Do I want to subtract the 4x and get it over with the 6x? Or do I want to subtract the 3x, or 6? I meant 3. There's a 6 there and it threw me. Do I want to subtract the 4x and get it over with the 3x? Or do I want to subtract the 3x and get it over with the 4x? Why would I want to subtract the 3x, Monica?
Because then if you subtract the 4, you're going to get a negative.
Well, not only am I going to get a negative, I have a number term right here. The point is to get the x's away from the number terms. They do not like each other. So we need to get them away from each other. If I get this, bring this over there, am I getting them away from each other? I'm just bringing more in. And then I'm going to get a 0 here, but because I'm an 8th grader, I'm probably just going to move my equals over there and just destroy the whole problem. Because you guys do that. So don't do that.
Not an 8th grader.
I know, 7th graders don't do that. 8th graders do. Well, the 7th graders do a little bit, but they don't do it as much. So we'll say the 8th graders. So I'm going to subtract 3x from both sides over here. So I get 604 equals, and I'm going to show you something that showed up on an assignment yesterday. What's 4x minus 3x? X. But I had a kid write 1x. And then they divided both sides by 1. Do you need to do that? No, because once we have 1x, and it wasn't wrong, it did make me chuckle. So it's just an extra step when you're making more work. 1 is something that can turn invisible when it's in front of an x, and we just have 604 equals x, which is a large number. But x could be 604, we don't know, right? I could have, at the beginning, done the -6 plus 157 and had 3/4 x plus 151. My life would have been a little bit easier, but it really wouldn't have made that much of a difference, okay? So are there any others on the assignment that you look at and you're just like, how in the world would I even begin this? And I'll do one that's similar to it on the board. Don't me just like, because you know how to do every process that's on there. They're just combined in a lot more steps. But you guys can do this, okay? It's just a matter of just going through, okay, what do I do first? What do I do second? What do I do third? You might be distributing and combining like terms where in the past you've just distributed or you've just combined like terms. We're going to do a little bit of everything on this one. Anybody have any more you want me to do with something similar on the board? Okay, if I put this pen down and everybody's hand immediately goes up, I'll be grumpy. Are you planning on raising your hand? Okay, then ask me now, Tayson. Because I guarantee you, Tayson, if you have a question, somebody else does too. Which one, Tayson? Number 8. I think you guys think that you're individually the only ones. Oh, that's a good one. Thank you for asking me on that one, Tayson, because that is a good one to show. I'm not going to do that exact same one. Give me small numbers, guys.
6. 2. 0.25.
It's a little bigger than that. 2x plus 3x minus x over
9.48.
5 equals 9.48. Yeah. I didn't want to have a fraction within a fraction, Coulter. All right, so I have 2 choices here. I can combine my like terms first, or I can multiply by the 5 first. Okay, so let's say I just look at this and I'm immediately like, fraction! I don't want fraction, so I'm gonna get the fraction out of my life. So we have to remember, when you have a bunch of terms on top of a fraction bar, they act as 1 unit, okay? So when I multiply this by 5, and multiply both sides by 5, because these are all 1 unit over the 5, when I cancel the 5, I cancel it for everybody. Now, on that last one, I multiplied the 4 by absolutely everything. Why am I not multiplying the 4 by absolutely everything here, Maddie?
Because it's all on top of the 5, and so they all don't need to be multiplied by 5 because they already were, but the 5's canceled out.
Right, so like if I had 2x over 5 plus 3x minus x, then that 5 would cancel there, but it would be distributed to these 2. But since they're all over 5, when I multiply by the 5, it cancels it for everybody, which is lovely, actually. Except it doesn't cancel it over here for Coulter's mess of a number. So we have 2x plus 3x minus x. Coulter, what's 9.48 times 5? I cannot do that math in my head. 47.4. All right, let's do this over. Okay, I was worried about something. What's 2x plus 3x?
5x.
Minus x is
4x.
Then we have 4x equals 47.4. I'm not going to finish this one to the end because you guys know how. Yes, Tayson. Yeah, we'll divide it by 4. I'm not going to finish it. This isn't on your assignment. Doesn't do us any good to finish it. But does that help you out with problem number 8? It's really, really similar. Same process, different numbers. Thank you for asking, Tayson. Anybody else who's going to raise their hand the second I put my marker down? And I'm going to be like, Thank you for that, Jackson.